Everybody, hope you're having a great day. Today we're going to introduce our next unit by talking about something that you guys should be really familiar with in slope. Now it's been a little while since you worked with slope, so we're just going to do a little quick review, see if there's some stuff that's new, maybe you haven't seen this formula before, and then just kind of review some things you already know about slope. So let's go ahead and get started. Alright, so if you take a look at this picture, and I just asked you which roof here is steeper, the roof on the left or the roof on the right, I think if you guys took a second, you might be able to figure it out, or you think you might be able to figure out. But what would probably happen is you wouldn't be 100% sure. It's tough to tell, especially from a picture like this, which roof is steeper. And so then in mathematics, we have something we call slope, which helps us measure the steepness of something. Steepness of a line is what we use in algebra, but we could use it to measure the steepness of a roof. But to figure out how steep it is, what we do is we just measure how, or compare how the height changes compared to the horizontal, like the length of it or the run of it. So you guys probably have heard of slope before as rise over run. What we're going to look at today is how we can find that rise over run, not necessarily just by looking at a picture. I think you guys have done a lot with slope triangles, and you can find the steepness of a line looking at a picture, just counting how much it goes up versus over, rise over run. But what we're going to look at today, because it'll be important for us for this next couple lessons, is determining the slope if I gave you 2 points. So if the problem just said determine the slope of a line that would be created by connecting the points 2, 5 and negative 2, 8. Now again, remember 2, 5, that's the x coordinate, 5 is the y coordinate, so 2, 5 is 2 over and 5 up on a graph, and the point negative 2, 8 would be negative 2 over and 8 up on a graph. So that's kind of how those point systems work if you had forgotten. And so if I just made a line and connected those points, and I said, well, let's determine that slope, we could count how many times it goes down and how many times it goes over to get from this point to this point, rise over run. So it went down 1, down 2, down 3, and then it went over 1, 2, 3, 4. We could just count it and get a slope that says, well, this line's definitely going down. It's going down 3 over 4. But what if I didn't have the graph? And that's what we're going to look at today. What happens if I don't have a graph? What if I am just given this and I want to find slope? To do that, we're going to use something called the slope formula, which is this right here. And so we're just going to spend some time. If you hadn't seen it before, I'm going to show you how it works. If you have seen it before, we're just going to review it. And so we're going to go ahead and switch over to the paper so you can see what it looks like in this class. Alright, so here's that same problem, but just asked on paper here. It says, find the slope of a line that connects the point 2, 5, so the point that's 2 over and 5 up, and the point that's negative 2 over and 8 up. And we're going to use this formula right here to help us find the slope or the steepness of that line. This formula here helps us find the rise over run by looking at the y values, particularly on the top, and saying, well, how far apart are the y values? To find the distance or how much it went up or down, we can just subtract those two numbers to figure out how far up and down it went. And then we can do the same thing with the x values, the 2 and negative 2, to figure out how much it went over. One of the things that's important, though, is just understanding what you're looking at with this formula. This y, it says m equals, m again is the abbreviation for slope. So if you didn't know that, slope is abbreviated by the letter m. Slope is the second y value minus the first y value. So when they write y2, with that 2, it's written smaller. So we can have, 2 next to the x, where it means 2 times x. We can have x with a 2 up above. That means x to the second power. And we can also have x with a 2 written underneath it. So we call it a subscript, or smaller. If it's ever a subscript, it's talking about which x am I talking about. So x2 means the x value of the second point. So it's not a math operation, it's a way that we kind of describe which x I'm talking about. Because if I give you 2 points, there's 2 x values. The 2 here is an x value, and the negative 2 here is an x value. So to tell them apart, to say which one I'm talking about, they leave these little subscripts. So x1 means the x value of the first point, and x2 means the x value of the second point. And we can do the same thing with the y values, because remember, every point is x then y. We can talk about this x value, or this y value, and this y value because this is the y value of the first point, we would call this one y1. And because this is the y value of the second point, we would call it y2. So one of the first things you just want to get used to is just what you're reading. And so when you see this slope formula, and it says the slope is equal to the second y value, that's y with a little sub 2, minus the first y value. So that's how we're going to determine the rise of this. This is the rise. Over, because slope is written as a fraction, the second x value minus the first x value. And because this is the x values, that's how much it goes over, or we call that the run value. So if I'm doing this slope formula, again, it's something I memorize over time because we use it quite a bit. It says take your second y value. So I got to look at my 2 points. Of these 4 numbers, which one is my second y value? Now remember, points go x, then y, x, then y. So the second y value is going to be the 8 right here. So I'm going to take the second y value, 8, and I'm going to subtract it from the first y value. So my first y value, again, I come up here, that's an x, that's a y, this is the y of the first one, so that's what I'm going to subtract. So I got my second y minus my first y, divided by, and let's do the same thing on the bottom, but I'm subtracting the x's. Now you do want to make sure that you take your second x and subtract the first. So I'm going to take negative 2, and I'm going to subtract it from the first x, which is 2. And at this point, I'm just going to do that math in my head. 8 minus 5, that is a 3. And then on the bottom, negative 2 minus 2, that's negative 4. A positive divided by a negative is negative, so I know that this slope is negative 3/4. Which is what we saw in the picture. It went down 3 and over 4. So we can use a slope formula so we don't have to draw the picture of it. We don't have to draw it out and then go, it went down 1, 2, 3, over 1, 2, 3, 4. And so those points have a slope like that. We don't have to draw it. Instead, we could just use the math to figure out the rise over the run. And we can just go from there. Let me just show you one more that kind of can trick people when they're doing the math. Not that it's any different, it just some people aren't as good with negative numbers. So we're just going to look at one more, and then I'll have you guys try some out. Make sure you get the right idea, and then we'll be set to go to start our next unit. All right, let's finish up with this problem here, just so you guys can see one that doesn't have all the work on it. So you'll be looking at a problem that says find the slope between these 2 points. So in my head, I'm picturing a point that's 4 over and 7 down. So if I have kind of a graph in my head, I'm thinking 4 over, so that point's way down there. And the other point, negative 2, 10. So these points are pretty far apart, and I can tell the slope is kind of going down, so I should expect a negative slope, and it's pretty steep. So I have some things I can do before, but I don't want to try to count this because then I would have to set up a grid for all of these, a coordinate plane, count them. So I'm just going to use the slope formula instead. So this is something you'll need to memorize. The slope formula is the second y value minus the first y value. Again, we start with the y's because the y's explain the rise of our slope, divided by x, this 2, or the second x value, minus x1. And so if I had that formula, let's say we have it written on the board, what you really have to be able to do is look at these points and know when it says y2, which of these 4 numbers is the second y value. And again, remember, points go x, then y, x, then y. So if you just want to always put x, y, and then just say, well, this is the first one, this is the first point, this is the second x, the second y, just by labeling them ahead of time is going to make your life a lot easier. At that point now, you're just going to take those numbers and plug them in each of the spots. So in the y2 spot, I'm going to pick 10 minus, and so remember, it's always minus. We're trying to figure out how far apart they are. So we subtract to figure out how far apart something is. 10 minus the y1 value. Now this is the reason why I want to show you this one. Look what happens. I have 10 minus, what is our y1 value? It's not a positive 7, it's a negative 7. So we end up with 10 minus a negative 7 divided by x2 minus x1. And so then I can go to the bottom and do the same thing and say my x2 is negative 2 minus my x1 is 4. And at that point, it's just a matter of doing the math. I just want to make sure we remember when we're subtracting a negative, It's kind of the same thing as addition. Now you could type this into a calculator and it would give you the right answer as long as you typed in 10 minus a negative 7. Or you could also just know that when you subtract a negative, it's the same thing as adding. So this just becomes 10 plus 7, which is 17. On the bottom is negative 2 minus 4, which is negative 6. And so because that slope has a positive divided by a negative, I know that it's going to be a negative slope, which is what I thought at the beginning. And if this fraction could be reduced, we would reduce it. This 1/17/6 can't be reduced, so we're just going to leave it as 17 over 6. So again, the only thing I wanted to show you on this one is if you subtract a negative, don't forget that subtracting a negative number is the same as addition. And if you didn't, let's say you just did 10 minus 7 and got 3, well, it doesn't make sense that this only went down 3 to get from here to here. So having that little visual to kind of start to go, yeah, it looks like this is down about 17 and over about 6 helps. Even if we don't count them, just having that visual can help us kind of double check our math, that we don't make a silly mistake. So we're going to have you just do a few of those before we start our next unit on graphing. As always, if you guys have questions, reach out to us. We'll be more than happy to help. Have a great day, and I'll see you soon.